So here are the notes for our chapter 8. I figure I'll just kind of pick up right where we went left off. I just want to let you know though that when we return, we will pick up right where we left off. So this is more of like a continuation of what we had been doing, or like a preview of what else was going to be coming. Additionally, in the exact same folder as this, there is polynomial practice worksheets as well. And then remember that I'm still available through email or through Schoology if you have any questions. All right, let's go ahead and dive into this. So we want to be able to write the functions, and I do want to put them in least degree. So don't want to add in more stuff than I absolutely have to. And additionally, I want this to be in standard form, which means everything is going to be multiplied out once all is said and done. Okay, so I know that roots come from solving for x in an equation. So the first thing that I'm going to do is take each of these roots and I'm going to set it equal to x. And I'm just going to try to back my way up through the problem. Now, if things are roots, then that means that I would have plugged in 0 for y. So ideally, I want to try to get these equal to 0. But I don't want to do any fractions or decimals, to be honest with you. So for the second one, x equals -4, this one's not so bad. I'm just going to try to crush everybody on the same side of the equal sign together. So I am trying to get equals 0. Okay, so that gives me x plus 4 equals 0. And then this one, I want to get rid of that fraction first, personally. So I think I'm going to multiply the whole thing by 3. So that'll give me 3x is equal to 2. Okay, fraction's gone. Now I'm going to move the 2 over with the 3x. So again, I'm trying to get that equals 0 business. All right, now that I've gone ahead and done that, these two new things that I just created, the 3x minus 2 and the x plus 4, if they're equal to 0, then that means that I can rewrite them as factors. Actually, that they are factors. So I'm going to get rid of the equals 0 part, and I'm just going to look at the x plus 4 part and the 3x minus 2. So now I'm going to take those guys. Now you can even set this to function notation, f of x, or you can set it equal to y. It doesn't state one way or the other. So I think I'm going to go ahead and do it as y equals. So I'm going to take y equals, and then I'm going to take each of the factors that I just got, which was 3x minus 2 from the fraction, and x plus 4 from the -4. Notice that I dropped the 0 at this point, and I replaced the 0 with a y itself. Last thing I need to do is multiply this out. So at this point, if you use the boxes to multiply stuff out, then that's what you should do. As a reminder, basically what this looks like is that we would have our 2 by 2 box, we would have the 3x minus 2 and the x plus 4. Now, I know some of you don't use the boxes to multiply and don't really have to. It's just a tool to help you. So if I multiplied this out, I know that one of the things inside the boxes would be a 3x squared, which would be down here in the bottom left. Additionally, I would end up with a positive 12x. That would have been up here. And then I have my negative 2x. That would be in this bottom corner. And then I would have ended up with a -8 as well. So again, the box is just a tool. If you want to use it, go right ahead. If you don't, well, that's totally fine as well. And then go ahead and combine like terms. Let's go ahead and put this in descending order. So I want the squared to come first, then I'm going to put the x second, and then my constant last. Okay, there is my polynomial function, just so happens to be a quadratic, of least degree, so I didn't add more stuff in than I had to. In standard form, it's all multiplied out, and I know that I used the roots to get the factors. So that's my answer right there. So let's go ahead and highlight this guy. So that is my final answer. Okay, let's move on to the next one. All right, kind of the same idea. I need to be able to identify that x-intercepts are number comma 0, so that's important, and that x-intercepts are technically roots as well, or zeros, which means I can set x equal to them. So if I take a look at this first ordered pair here, I notice that it is an x-intercept. I know that the x value is 3, so x equals 3 is a 0. I want to write it as a factor, so I'm going to subtract the 3 to the other side. So I get x minus 3 equals 0. Okay, so that is one of my factors. Get rid of the 0 part. Okay, now I'm going to move on to the next one. Again, I'm only going to do this if the ordered pair is something comma 0. Okay, so this one, same idea. That gives me x equals 1. Subtract the 1 to the other side. That gives me x minus 1 equals 0. Okay, I have equals 0. That is also going to be a factor. Okay, moving on to the next one. That ordered pair is also comma 0. So I'm going to get x equals negative 4, add the 4 to the other side, and that's going to give me x plus 4 equals 0. Okay, it's equal to 0. That's a factor. Okay, now let's take a look at this last one. This last one is not equal to 0, which means this is not an x-intercept, which means it is not a factor. This is merely an x comma y. So we'll come back to that guy in just a minute. So basically I'm going to proceed like I would first semester when we were trying to find a, so like the leading coefficient on a quadratic. So I'm going to take all of these, the red, the green, and the blue, and I'm going to rewrite them as y equals, I'm going to leave a little bit of space right there because I don't know what the leading coefficient is, and then I'm going to bring all the factors with me. So I had an x minus 3 from the first one, I have an x minus 1 from the second one, and then the last one that I had, not using the purple point because it's not an x-intercept, is x plus 4. Okay, our leading coefficient has always been and will continue to be identified using the letter A. So in that blank spot, I'm going to put a lowercase a there. I don't know what it is, but I can find it if I use the purple point. So back into my equation, everywhere I see an x, I'm going to plug in a 2. So I'm going to plug in a 2 there, I'm going to plug in a 2 there, and I'm going to plug in a 2 there. I'm going to drop everything else down in just a second. My y, I'm going to plug in a 3. All right, let's drop everything else down. Got my a. Bring down your minus 3. Bring down your minus 1. And bring down your plus 4. Now at this point, if you take a look, the only thing that is unknown in your equation is the a itself. So now let's just clean this up and solve for a. Following order of operations, I've got a 3a. Okay, that gives me a negative 1. That gives me a 1. And that gives me a 6. Everything on the right-hand side is strung together with multiplication. So let's go ahead and multiply the numbers here that we've got. So all those guys, and I think I get a negative 6, then that is being multiplied to the a. I like my variable, or my unknown to come second, so then I know how to solve this. I would go ahead and divide by negative 6 on both sides. Let's cancel, and yes, I'm going to go ahead and simplify this. That gives me negative half is equal to a. Okay, now that I have that, I can now take the a that I found here and plug it in back here. So my final equation is going to be y equals, plug the a in, negative 1/2. Now continue writing the rest of the equation with the factors in it. X minus 1 and x plus 4. Now if I take a look back at the directions, it doesn't say that it has to be in standard form. And I'm a big fan of not doing any extra work that I don't have to. So I believe that this is my answer. If it said that I had to put it in standard form, then okay, I'd multiply it out. But it didn't say that. So this whole thing is my answer in factored form. Okay, moving on to the next page here. We've got some more problems and we're being given the roots as well. So what I would like to do, remember roots can be written as x equals. So I'm going to write them as x equals. So each one of these is going to be identified as x equals. So x equals -2, x equals square root of 3, x equals negative square root of 3. Something important to note here, and this goes way back to integrated 2. Whenever you guys have a answer or a root that is like, or a root or a 0, that is like a square root, so like square root of 3 in this case, you have to imagine where these would have come from. And if we're thinking back to prior knowledge, the whole idea of the quadratic formula, the root has a plus or minus in front of it. With that said, whenever you see an answer that has a square root, like this 3, so if we look up just the first one, if you have a positive, then you better have the negative as well. And that's because of the quadratic formula. So if you ever see like the square root of 7 is a root, we know for sure that negative square root of 7 is also a root. So they have to come in partnership. So there's little pairs that come out of this. Okay, go ahead and continuing with the rest of this question. I would go through and rewrite each of these as equals 0. So trying to get the factors out of this. So I would add the 2. I get x plus 2 is equal to 0 minus the root 3. I get x minus root 3 is equal to 0. And then the last one, adding the root 3 over to the other side, that would give me x plus root 3 is equal to 0. Okay, now that I've done that, I have all of these guys. Since they're all equal to 0, then I know that I can pull the factor out of it. So x plus 2, x minus root 3, x plus root 3. Let's go ahead and string these guys together. Now, I wasn't given any information about going through a specific point, so I'm not going to put an a value there. So I'm just trying to find a general equation for this thing. Additionally, it didn't say to put it in standard form or factored form. However, on first glance, I kind of cringe just a little bit. I don't have a problem with the x plus 2. That doesn't bother me. The x minus root 3 and the x plus root 3, I do have a problem with. Oh, and now that I take a look at the directions, it did say I had to put it in standard form. So I'm going to go back to page 2 again in just a second. So I got to multiply this out. So I do have to multiply out number 2. So we'll go back to that guy. If it were me, whenever I have the plus or minus, the two factors that look almost identical, I'm probably going to multiply those out first. These are technically called conjugates if the constant that's being added or subtracted is identical, except for the signs being changed. It's actually kind of nice when you multiply them out because the middle terms, so like the x terms, are going to cancel out. So I am going to go ahead and draw the box off to the side for this one, so I think that might be beneficial for people to see. So I'm going to multiply out the x minus root 3 and the x plus root 3 first. So if I do x minus root 3, x plus root 3, well, I know that's an x squared. Oh, that works the way that it normally would. You just kind of mash the things together. Now, a negative times a positive is definitely going to be a negative. If you're timesing root 3 times root 3, you're technically doing root 3 squared. So this is going to give me root 9, which is the exact same thing as 3. Notice the magical part that I just talked about here. The x term here and the x term here are going to cancel because they're the exact same value with opposing signs. So those go away. So when I multiply out the x plus root 3 and the x minus root 3, I get an x squared minus 3. It's actually really nice. Then I'm going to go ahead and bring down my x plus 2 because I haven't multiplied that out just yet. Okay, now you need to continue multiplying this out. So now would be a good time to pause. Go ahead and multiply it out and see if we get the exact same answer. Okay, so this is what I ended up getting. I chose to put it in descending order since I kind of like them organized that way. So here is my polynomial function in standard form of least degree, so I didn't add any other stuff in. And I should have expected an x cubed because I had 3 roots. So if I have 3 roots, chances are I'm getting an x cubed, especially if it is least degree. Okay, so I went ahead and flipped back to the previous page here. Since it did say standard form, I guess I have to multiply it out. So my recommendation to you really is to multiply out the factors first, and then the very last thing you want to do is multiply out the negative 1/2. Now, it doesn't matter which of these factors you multiply together first because none of them have the same constant inside. So it's not like they're conjugates like we did on the other example. So I am going to multiply out the x minus 3 and the x minus 1 first. So, won't you pause me? See if we get the same thing for multiplying that out. Okay, this is what I got from those first 2 factors, x minus 3 and x minus 1. But I got to keep going. So standard form means everything is separated out together. So now I'm going to take the x squared minus 4x plus 3, and I'm going to multiply that to x plus 4. Once you start having terms that have more than, or start having factors that have more than 2 terms in them, you really might want to draw the boxes on this one. So why don't you go ahead and pause me, multiply out the x squared minus 4x plus 3 times the x plus 4, and see if we get the same thing. Okay, so something nice actually happened here. My x squareds ended up canceling out, which, less terms to deal with. All right, I'm in the home stretch. I'm almost done. Last thing I need to do is distribute the negative 1/2 out, and I'm kind of running out of space, so I'm going to go over here to the left. So go ahead and distribute your negative 1/2. Remember that to multiply fractions, you do top times top equals top, and bottom times bottom equals bottom. Let's go ahead and pause, see if we get the same thing. Okay, I think I'm done with this problem now. So I went through, I multiplied it all out. No factors, viewable. They're still in there. I just can't really see them. That is my answer in standard form. But to be honest with you, in problems like this, I'm probably going to ask you for the one in factored form instead. So back here at the green guy. All right. So what I've done on the next couple of slides is given you guys some examples. So I highly recommend that you practice. So I'm going to make them visible to you, then pause me, and I'm going to go through and work them out so that you can see if you got them correct or not. Okay, so here's the set of examples that I want you to work on. Quick clarification though on the way that I wrote number 4. When you see a single root, a double root, a triple root, etc., you're being told about multiplicity on that factor. So it's basically telling you if that factor has an exponent or not. So keep that in mind. Additionally, I don't want these in standard form. You can go ahead and put them in factored form. So right now would be a great time to pause, see if you can complete question number 4 successfully, and then unpause me and check, and then do the exact same thing with question number 5. Okay, so hopefully you were able to successfully complete question number 4. Let's kind of check it out. All right, so I know that a single root here, let's see. So my single root at 7 is going to give me a factor. I'm going to kind of jump to straight to the punch here. It's going to give me a single root at x minus 7, or single factor at x minus 7. Okay, moving on. I have a double root at negative 2, which means the factor is going to be x plus 2, but because of the double root, it's going to get an exponent of 2. Then, if I take a look down at this last part, it goes through the point 1, 6. Okay, not an x-intercept, not a root, just a point. All right, go ahead and start writing my equation. So I have y is equal to, I don't know what the leading coefficient is, plug in my x plus 7, plug in my x plus 2 squared. Now I'm going to go ahead and take that x comma y and plug it in. So the y was 6, the x was 1. All right, now drop everybody else down. Oh, it's not supposed to be a plus sign, it's supposed to be a minus. 1 plus 2 squared. Okay, go ahead and clean it up. Gives me a -6. That's going to give me a 27. Now, I'm not going to multiply this out. I'm just going to divide by -6 times 27 because I see something kind of nice here. So those cancel. Now, if you look on the left-hand side, the 6's are going to cancel as well. So if I don't have anything upstairs, I'm going to have a 1. I have a negative sign. I like to put it on top of the fraction. I got a 27 on the bottom. All right. I got my equation. It's going to be -1 over 27 is my leading coefficient. And I'm just going to bring my factors with me, x minus 7 and x plus 2 squared. Okay, that is my answer now to the first question, or question number 4. All right, go ahead and pause me. See if you can do question number 5, and then check back in. Okay, hopefully you've had the opportunity to go ahead and work on this question. All right, so everything that is an x-intercept can technically be written as a factor. So this would be x plus 4, x minus 2, and x plus 1, and that is just a point because it is not an x-intercept. All right, I don't know what my leading coefficient is, so I'll put an a in there. Bring down my factors. Now, since there wasn't anything identified as multiplicity here, or double root, single root, triple root, etc., and I'm doing least degree, that was the directions here, don't add any exponents in. You're just going to make it harder on yourself anyway. So we're doing the best that we can with the information that we have. Don't assume that something bounces or twists at any location. All right, let's go ahead and plug in the -3 and the 8. There's my 8. There's my -3. I'm just dropping them into the x locations. All right, let's bring everything else down now. And clean it up. Now, I don't see any of that kind of slick business. Well, kind of. I mean, the 8 and the 2 might be able to simplify. Let's do that. So I've got the 1, the -5, and the -2. The 1, the -5, and the -2. Okay, cancel, cancel, cancel. All right, I don't need the 1, so I didn't have to do that anyway. I can simplify the 2 and the 8 though. So 2 goes into 2 once, 2 goes into 8 4 times. I have 2 negative signs on the bottom, so this is positive, and I have a 4 on the top, and the only thing that's left on the bottom is a 5. All right, so it looks like I have 4/5 is my leading coefficient, and then I'm just going back to where I had my factors. So x plus 4, x minus 2, and x plus 1.